All right, it's a tiny glitch there. I had to create a second video. So moving on to problem number 1 in the apply and evaluate section. So we are looking to simplify this. Pythagorean identity, sine squared plus cosine squared is equivalent to 1. So now I have a difference of squares. I can factor this into sine squared of x minus cosine squared of x times sine squared of x plus cosine squared of x. Again, Pythagorean identity. We know this is equal to 1. So I'm left with sine squared of x minus cosine squared of x. So that is one possible final answer. Some of you took it a step further and converted sine squared to 1 minus cosine squared. And that led to 1 minus 2 cosine squared of x. So one answer here. I accepted this answer. That was awesome. And this is my problem to see if people were using their own notes or if they're using an online program. Because as far as we learned, this is as far as you could go. Anybody who got the answer, negative cosine 2x, I know you used an online program. This is called a double angle identity. You will learn it in calculus. We have not learned it. We have not gone over double identities, but that is the simplest form if you used an online program rather than your own knowledge. There will be tests like this within the assessments coming up. Please make sure you are paying attention to your own academic integrity, and going forward, do not use online programs to help you. This has been your PSA. Moving on to problem 2. Cotangent I can change to the cosine of x over the sine of x. Secant is equivalent to 1 over the cosine of x. And the sine of x is already in terms of sine. So I have a denominator sine and a numerator sine, a denominator cosine and numerator cosine. So I have 1 over 1, which is equivalent to 1. And that is our final solution. The third problem in simplifying, I'm going to convert everything into sine and cosine. So tangent is sine of x over cosine of x. Cosecant is 1 over the sine of x. And sine of x is as it is. So now there's a couple of ways to proceed from here. Some simplified inside parentheses, some distributed. I am going to distribute. So I will have sine of x cosine of x times 1 over the sine of x. From that, minus sine of x cosine of x times negative sine of x over 1 from that distribution. When I do that, I end up with 1 over the cosine of x minus negative sine squared of x over cosine of x. So I see these have a common denominator. My numerator becomes 1 minus sine squared of x over the cosine of x. 1 minus sine squared is a Pythagorean identity, which is equivalent to cosine squared of x over the cosine of x. I can then cross out, and I am left with the cosine of x as my final solution. And the final problem in this section. Couple ways to do it. I'm going to show you the most efficient way. Tangent squared is one of my Pythagorean identities. It is equivalent to secant squared of theta minus 1. So I can factor the top to the secant theta minus 1 over the times the secant of theta plus 1 all over the secant of theta plus 1. I still have this plus 1 out here. I can now cross out here and here, which leaves the secant of theta minus 1 plus 1. So I'm bringing that over. This whole thing is canceled out. -1 plus 1 is 0. So I'm just left with the secant of theta. And that is my final solution for number 4 in the apply and evaluate section. Moving on to the third competency, justify and prove. You are verifying these trig expressions on the left is equal to the trig expression on the right. So I'm going to convert everything into sine and cosine. So secant is 1 over cosine. I already have this converted into terms of sine and cosine. So on the first fraction, I'm going to multiply by the reciprocal of sine. This is going to get me 1 over cosine theta sine theta. And bring down my second fraction. To combine these, I need a common denominator. So my common denominator is going to be cosine times sine. So I need to make sure I multiply my denominator by sine. If I do that, I have to multiply my numerator by sine. I have 1 over cosine theta sine theta minus sine squared theta over cosine theta sine theta. Common denominator, now I can combine them. So I have 1 minus sine squared theta over cosine theta times sine theta. 1 minus sine squared is one of our Pythagorean identities. It is equivalent to cosine squared. As everything is joined by multiplication, I can cross out cosine and one of the two cosines on the top, which leaves me with cosine theta over sine theta. And that is equivalent to the cotangent of theta. If I go back to my original problem, I'm looking to prove that it is equivalent to cotangent. I have done so successfully. The second of the two verification problems. Most of you guys did really well and recognized it right away that the secant squared theta minus 1 is equivalent to tangent squared theta. So we have tangent squared theta times cosine squared theta. Tangent is sine squared over cosine squared. cosines are going to cancel out, and I'm going to be left with sine squared of theta. And it was as simple as that, because that is what I am trying to prove. All right, I'm moving on to the final competency, create and build, as well as this communication score. So if your communication score was low, it's because you did not answer in a complete sentence with the correct units, combined with problem number 1, answering in fraction form. Let me sketch out my diagram. We didn't have to get as detailed as this, but what the heck, we're in quarantine. I got some time. So I got an owl. Admire the artwork. Sitting on a branch that is 24 feet above the ground. It is watching a little mouse play. That is an amazing mouse. And here's where some of you got mixed up. The angle of depression is 65 degrees. So off the horizontal, the angle of depression is 65 degrees. Which means you could go one of two ways. The angle of elevation equal to that angle of depression would also be 65 degrees. Here's my right angle, which means this top angle inside would be 25 degrees. So again, angle of depression out here, 65 degrees. So you could set up a couple ratios here. If I'm going to use the angle of elevation down here, I want to know the distance the owl has to fly. So I would use opposite hypotenuse, that would be the sine. Equals the opposites over the hypotenuse. Your other option would be use this angle up here, the 25, in which case I have the adjacent hypotenuse, which would be the cosine. I don't know why that black line keeps popping up, but we'll roll with it. So to get x out of the denominator, I need to multiply both sides by x. And then to get x by itself, we need to divide both sides by the sine of 65. And I would do the same thing if I use cosine. So when I plug either of these into my calculator, x equals 26.48 feet. So for my communication, The owl would have to fly 26.48 feet to catch the mouse. And finally, you get two observers 100 feet from the base of a building. They spot a radio tower at the top. The angle of elevation to the top of the building is 62 degrees, and the top of the tower is 68 degrees. What is the height of the tower? So as I said in the intro video to the assessment, we are just looking for that height right there. I need to know this total height, so I'll call that X, and this total height, I'll call that Y. So in both situations, I have opposite and adjacent sides that do not need the hypotenuse, so I'll be using tangent. So to find X, I'm going to take the tangent of 68 and multiply both sides by 100. So X equals 100 times the tangent of 68. And when you put that in your calculator, you get 247.5 feet. To find Y, again, I'm going to use tangent, except it's 62 degrees this time. And that's going to be Y over 100. So 100 times the tangent of 62 will equal Y. And using my calculator, 100 times the tangent of 62 is equivalent to 188.1 feet. So to find the height of the tower, I need to subtract 247.5 minus the height of the building, 188.1, and you should get 59.4. And then for your communication, the height of the tower is 59.4 feet. So this ends your solutions video for the assessment.